Introduce to you today Mr. Jim Prohaska. He's a professional engineer out of the Bryan College Station area. Jim has a degree from Texas A&M in both bachelor's and a master's of science. His specialty in PE was agricultural and civil engineering. Jim's been basically in the industry since 1987, and in 1994 really took a focus on effluent dispersal through drip distribution. Jim has a tremendous amount of experience in not only the design of smaller but much larger systems running into the millions of gallons per day, and also owns a filtration and supply company for drip distribution technologies. And J&M is one of just 2 systems that are available in the state for anaerobic distribution. So without much further ado, I will turn it over to Jim.
Good afternoon, everybody. All right, those of you who were here the last year at 4 o'clock, you enjoyed the last program with me then. So I was wondering if he slotted back into that wonderful hour of 4 before the, I'm between you and the bar, okay? So that's really what it boils down to. Okay, so what we're going to do today, and Sarah was a great walk into what we're going to talk about today. And we're going to look at surface drip, subsurface drip installation, but we're going to look at the aspects that also go along with it, which include the responsibilities of the designer, the site evaluator, or I call him also the site inspector, and the installer. And then in the end, we're going to try to move towards looking at, okay, you as the installers, most of you guys are going to be installers, you really got the last part of that. You're going to take the interpretation of 2 other people maybe, or maybe one person who does it all. In some cases, you as an installer, you're the site evaluator, you're the designer and the installer. So you're going to integrate all that together. And then so what I see, and what a lot of people, when you go out into the industry, is are there things that should have been, let's see, brought up? Because who digs the bigger hole? The installer does, right? Got to put a tank in there. You're going to go out in the field, you're going to put that drip line in, because we're going to talk about drip today. If you're looking for LPD, that's in the other room. So if you got the wrong room, so just make sure you got the right one. It's still underground, but ours is going to be through drip. So let's look at just real quickly, we're going to slide through some slides that talk about where is drip today for those of you who have not been in this for a while. I usually show these pictures of systems that we work with here in Texas and across the United States. Okay, here's more of what I would call a typical yard system here. You can kind of see that they haven't mowed the grass in a while. You can tell where each one of the drippers is at, and it's a really happy little system there, going great guns. And that would be more of our typical yard systems that we put in around here. Here's one that's it's a little more, let's call it, it's like landscape friendly. You can see the stuff's been taken and put into different kind of uses in there. We've got water going into the system here underneath it. You don't know where the drip system is in this particular one, but it's a very nice landscape there. That happens to just be in California there in that one. We do a lot of schools today, a lot of schools from our systems. Remember that our systems in this room, under the 285 rule, we're from 1 to 5,000 gallons per day, okay? That's a lot of water, 5,000 gallons per day. We do a lot of systems like that. That's a full-size, big commercial system, okay? Incrementally, it just gets bigger all the time, but that 5,000 is really a major stepping point. The equipment changes, the way you do things changes a little bit, but that's our responsibility in this room, okay? So we're let's quote-unquote, licensed to kill in that situation. Okay, this just has to be a school. Here's a system. How many people went to David Price's talk this morning, okay? If you talk about David, David did this particular system here, okay? This is Ledgestone. It was a 50,000 gallon per day system. This is over in the Austin area towards Dripping Springs, okay? And that's up and going, and it's getting ready to go into another phase. They've already built out here and getting ready to go again. Here's another system. This is 250,000 gallons per day. This happens to be over in Tennessee. I do a lot of work in Tennessee. Some of the bigger systems going in today go in the area of Tennessee. This is a lagoon system doing our treatment over here, okay? And then all around here in this wooded area here, all this is all drip. and big sprinkler systems to get rid of about 1 million gallons a day. Okay, we're getting rid of 250,000 just by ourselves with the drip. This is a 500,000 gallon per day system that was done up in the Panhandle of Texas. This is at Pantex. How many people know what Pantex is? Anybody? There you go. Okay, that's these are bunkers down here. If you've got an idea, that's not the feeding sheds or anything like that. This is where nuclear weapons are brought in. They're stored, manufactured, if you want to use that term, recycled, and brought back into it. It's a 6 mile by 6 mile piece of property. Okay, so there's a lot of area on there for farming. So we get to go on there and do some farming. So we were out there. They also produced about 500,000 gallons of water a day just in the wastewater, and that was just from the people that work there. Okay, so drip's come a long way, and that's just trying to get you to see. All right, so drip is not brand new. It's been around a long time. We've been talking about it in this particular setting with TOWA since the early 90s, and you know, it's not the technology of last resort. It is one of the best technologies because nothing else takes and moves water into the soil better than drip does. But a lot of people have kind of a phobia against using it and things of that nature. So I don't know, in an hour I can give you that type of knowledge. We're going to talk and sit and look at some of the aspects of the things that give us heartache and cause us to pause, okay, when we're looking at these. So we'll look at systems from homes. We'll look at systems for a little bit larger commercial type things. All right, so let's just step back and let's see how this thing all breaks out when we start with this thing. Okay, even though you're the installer, this doesn't start with you. Sometimes it does start with you. I've met a lot of installers in the Austin area. Oftentimes, they're the ones that know the homeowner. They know the builder, and they're bringing the design forward that way. All right, so that's not an unusual situation. So I talked about the main players in the beginning, or the homeowner, builder, and developer. It may be actually the on-site, the installer may have been the one, because he's the guy out there. He's the one that people see and talking to them. But let's look at the jobs of each one of these and where they play into it. And sometimes this homeowner, builder, developer should be reversed from developer, builder to the homeowner, because the homeowner may be the last person in this thing. And so we'll look at that. The other thing we look at in number 2 here is the on-site designer, which is going to be a professional engineer or a registered sanitarian. All right? And then feeding into that design process, we have the site evaluator. This could be 2 people. It could be the designer and site evaluator, or it could be just the designer by himself, and he goes out and looks at his own stuff, okay? And then at the end here, we're going to have the installer who's going to bring all this together, integrate it together, and get it out into the field. Okay, the homeowner, that's the dreamer, right? Or the developer. They're going to be the ones with, oh, I want to do this and all that stuff. I want to build a dream house and all these good old things. Here's the site plan here, the beginning of an early plan, just laying it out. You get to sit there and talk to your building designer and say, yep, that's it, and this is what the picture might be. Think about that. And what the picture might be here of what our home's going to look like. So that's our dream place. Okay, we're going to put it in the best piece of the property that we're going to buy, and typically the wastewater is going to go in the worst piece. Well, that shouldn't be that way, but that's what happens. Because unfortunately, they didn't bring the installer in early enough to say, is that really a good idea? For some reason, designers are failing us in some cases. I'm not picking on designers. I am a designer too. I'm a PE. But sometimes we don't get the chance to say, this is the better piece, okay? All right, let's take a look and go on here. Okay, so the designer and then the site evaluator, or the site investigator, which he should be, you're going to go out there, you're going to get the plat, you're going to get to look at, okay, this is the piece of ground, that's the property bought and purchased, okay, and this is sort of the early on plan of laying this big old house, I mean a big old house, driveways and all these kind of things, and so this poor guy here, with his magnifying glass, with his shovel, with a small backhoe or something, is going to go out there and make some determination as to what the kinds of soils there are. He's going to make some determinations as what's the things going on around him. He should be. And dig down deep enough into this soil to see if we've got anything, if we've got a high water table situation, and we've got rock. What's going to be the conditions here for putting this system in, and where am I going to be at with respect to the house, the landscape, and the borders of the property. We have to stay off of each one of these things. We have certain rules. Then he's going to have to, as a designer, he's going to choose whether or not I'm going to go in here with aerobically treated or anaerobically treated effluent, and each of them will, they have their pluses and minuses, okay? But they also have requirements as to where they might go in. Okay, and then finally, but not least, we have our installer, okay? So typically you're thinking that I'm going to take a set of plans, I'm going to go out there and do exactly what the guy told me to do, and I'm going to put this thing in and not worry about a darn thing. Or I'm going to go out there and find out in reality that, hey, when I started digging in here, I dug all these trenches. You know all the beautiful soil colors in this thing. It's like a rainbow almost, okay? Each of those soils, each of those layers in there has different hydraulic characteristics, okay? Water's going to move through them differently than they do from this surface type, which is going to be a little more, see, a little darker, a little more organic material in here. And then the subsoils in here are going to be a little bit less organic material in there, maybe a little less oxygen. And then some of these things are going to go on. So you're going to see that stuff when we start digging, because we're going to dig big holes. We're going to put our tanks in here. We see our guys down in the hole here and making their way. Then, on top of the ground, once we've got this, we've got to set up our area where we're going to, once again, get rid of our water or to disperse our water. We're not throwing it away. We're going to put it back in the ground. We're going to reuse it to some degree. That's an important feature when we're up and around the Austin area, heading towards San Antonio, because it's all big-time recharge areas, right? Okay, so we have to be conscientious about what we're doing, you know, making sure that that's part of a plan. Again, sometimes you are the person who is interacting the most with the homeowner, and you as the installer, also the last person to interact with the homeowner, typically. And make sure that the design's going in and it makes sense. If you see errors and problems with that, don't try to necessarily make decisions and make changes there, but you're also going to be required to make changes and decisions going back to that designer. Let him carry that burden, because that's what he's licensed for, not you. But you probably have a better sense of what needs to be done, so be open with that. Don't just stand there and go, well, this is what he told me to do, so I'm not responsible. Okay. So what about the site? And who's responsible to gather the data and be responsible to interpret it? And who's responsible to make it work? Okay. And is the customer always right? And there's kind of odd phrases in there, but a lot of times the customer comes in there, and what happens when the customer tries to be right? He's trying to say, well, maybe we're going to make a little change here that we weren't thinking about 6 months ago when we started this process and when we laid the system out, okay? Pools and RV slips and a few other things typically come in there that they may have not bothered to tell the builder about, and they may have not bothered to tell the designer about, and then all of a sudden you as the installer are sitting there and going, well, we really want to put something here. And you go, well, that means we can't put our dispersal field here, so you're going to have to make changes. So we sometimes run into the problem with our customer, and maybe it's time to go and find out, get that customer back in line with the installer or maybe with the developer and the builder. Okay. So let's take a look at some of the things that we're going to bring into us. Again, you're not working on the design as much, but let's talk about what you're going to find in the ground and why you should understand it, whether you're putting in drip or your LPD or in some of the other systems. Okay, Sarah went through a good explanation about our good soils. Okay, our soil is our friend. It's a great friend. It takes care of us. It's going to be our final treatment in here. This is a very beautiful piece of ground in here. You see all kinds of layering and texturing in here, and the different demarcations in here. Okay, so you match the disposal system's design with the capacity of the soil to take up water. That's basically what you're doing, right? Okay, so if I've got 300 gallons of water a day, I'm going to have to say, okay, my soil is this. That was based on that discovery of our site investigator, or site evaluator, as we call him, your license is. And then we're going to take a look at how that all fits together. So let's look at here. Okay, so you understand the dynamics of water flow. Water flow is not going to necessarily come in and go straight down. Rarely does it ever do that. It's going to hit the different layers. It's going to move along sideways. It could be moving, and downwards it can go. If you're working around the Austin area, how far does water go down? Easily. it hits a bloody rock, okay? It's going to go bam, and it's going to start moving sideways, okay? We're usually bringing in soil to create our system there. So if you're west of I-35, you're in some troubled areas there. If you're east, okay, you're in the farmlands, okay? You're into the loamy clay soils over there. So you're not going to be able to load a lot of water into it, but you are going to be able to load water. Okay. So our site evaluator, when he goes out and does his investigation, is going to go out there and dig holes. He's going to go core some things out, get a better understanding of what all the layering is. He's got to do a number of these around to represent the dispersal area. And so he's going to take that, he's going to do texturing, which is an on-site type thing. There are other tests he can do. You can send some of this stuff to a soils lab. Texas A&M has a soils lab that does this type of thing. And try to figure out what's in this pile of stuff here. And when it's natural coming out of the soil, you're going to be looking at this texture. We talked about just in the last talk about plastic limits and things like that. So we're going to be testing all this stuff. We're going to look at all this stuff together, figure out, okay, in our simple way, we look at it in basically the textural triangle here of clay, silts, and loams here. And so we're going to look at our sand percentage, our silt percentage here, and our clay percentage over here, okay, and come up with where am I at. And what's important about this, we have a 1, 2, 3, or 4, okay? Texas is really simple on this, okay? Other states I work in, this list is very, very highly expanded, but Texas we look at trying to lump everything into this. So this is supposed to be everything, are all lumped together in here. So we're trying to make that distinction here. Well, because we only had 4 numbers on that page, what did we do? We came up with basically a 1, 2, 3, or 4 type of classification of our soils by textural analysis, okay? And so we're looking at running from about a 0.1 down here in what we would call a class 4, which is going to be a clay soil. It contains quite a bit of clay. And move on up to something in the 1A, and that basically 1A is what? Kind of gravelly sand. We're not going to be able to do a whole lot in that, right? We're somewhat restricted from that. And so we're looking at the 1Bs on down through 4. Our drip systems, unlike a lot of other things, are not limited by that characteristic, okay? We can put the drip into any of these soils. It will handle it, but it has to be sized. It has to be, you have to have enough of it if you're in a class 4 soil versus you can have a lot less when you get up in towards the 1B. Okay? So this is that first table that we go to, and we're going to look at 2 tables here that are kind of our governing bodies here. This is going to give us, with that number there and with the amount of water the house is going to generate, what do we have? What do we know then? That's going to tell us how big the system's going to be. It doesn't tell us the shape or anything, but it's going to tell us how many square feet of dispersal area we're going to have, right? Okay, and that's going to be important to you as the installer because you're going to take this design that this guy drew up in there and you're going to go out there and find out, well, there's a rock there that wasn't on your plans there. I can't get through that. You're still going to have to come up with a suitable amount of area. All right, this is table 13, okay? That's probably a good number for it. Not a great and happy table, okay? The state of Texas, in their infinite wisdom, have lumped all of our potential ways that we're going to do things, okay, we start with our soil structure over here. We have our various kinds of methods we use to treat and get rid of water over here. And then we're going to look at through the class of the 1As and then which are going to be our sandier fractured soils there. And we're going to look at over here our 1Bs through 3, 4, which is our clay soils, and then plain old fractured rock. We deal with a lot of fractured rock in the state of Texas. We have to deal with it, otherwise we're not going to be able to use the land that so much of our population wants to live on. They like to live on their rock, okay? So they're coming into Austin, they're coming into any of the beltway along the I-35 corridor, west of it, and that just seems to be the place everybody wants to live, but most of the time you're going to be living on some kind of a rock with just a few inches of soil on it, then that trickles on through there. So sometimes this fracturing is going to be a no-no. And why would that be? Why is that a problem? Say I throw 2 or 3 feet of soil on top of it, why is that going to be a problem? Soil erosion, but what the biggest thing is, in some cases, depends on what we're going to do with the water and how we're going to treat it, we're going to basically have a connected flow from that fracture on down to a water table, right? We're in a recharge area a lot of times. So that's a problem. So the tables have been adjusted to try, hopefully, to avoid you using that as a means, okay, for getting there. Most of the time we're looking at this kind of thing here. This is measurement this is the minimum depth to restrictive horizon, minimum depth to the water table. I apologize for the table. These are the big titles here, but they don't quite line up here. So this one and this one line up here and here, okay? It's kind of hard to read. And it's not a table that everybody likes to play with, okay? So basically, in a lot of times situation, the old traditional 2-foot is going to be what we're looking for between the restrictive horizon or water table down through, we're going to let the wastewater move through it. And then we've always, traditionally in the state here and in several other states, that 2-foot's been kind of the number. That's our VADOS zone. It's not saturated. Our treatment's going to go carry on through there, okay? So we're going to be looking at the table here with our drip systems here. We happen to fall in, okay? So this is the drip with septic tank. Basically, we're talking about anaerobic drip systems, okay? And here's one of these things is right here. It says it's not suited for use in sandy, gravelly soils, okay, which kind of makes sense. And it's not suitable to be used in fractured soils, okay, fractured limestone soils, okay? Then our drip system here, which is going to be secondary, is going to be suitable, but this class 5 here, and you see right here, that says you've got to disinfect it, okay? Because it's going to be moving through and down, out. So if we're going to be carrying pathogens, we want to kill them before they get out of control. The nice thing about the drip is, if you notice these numbers, 2-foot, 2-foot, and all these other things, 1 foot and 6 inches. 1 foot and 6 inches, okay? That's pretty good. That's to the restrictive horizon. Now, for the water, it's going to be a little more restricted back into 2 and 1 foot, but still we're dealing with 1 foot or 6 inches in here. That makes a drip a pretty nice fit, okay? It makes it a pretty nice fit in a lot of these systems because you don't have to have the depth here. I work a lot in Ohio, and drip is popular there because it can be used in these high water table areas for that same reason there. Okay, so down here, it's kind of low on the table for some of you folks here. The soil substitution, there were some questions about that in here before we shifted gears here. This is where you're bringing in basically the soil. It's not there. You're having to bring it in, so we're going to bring in a couple of feet of the soil, and we're going to lay it in here. Above the water, above the water table, or above the restrictive horizon, and then that's going to give us the 2-foot that we're looking at is our difference here between these, and then we're going to have to cap this thing. So in the end, it may say 2 foot there, but we're looking 30 to 32 inches typically. Okay, so two things here. This is table here. This is for the septic system, and for the secondary treated. If you're doing soil substitution, you're bringing all this soil in, it really doesn't make any difference. You're going to have a situation where you're going to have that much soil. So that little bit of 6 inches and all that stuff doesn't necessarily pertain. Unfortunately, I see some of that happen anyway in the permitting, and it gets allowed through there, but this is what it really says, okay? Okay, so let's look at site characteristics when you're going out there as the installer, okay? So supposedly somebody's taken all this in consideration and decided this is a 0.1 or a 0.2 loading rate. Okay, we've got slope in here, field orientation, okay? For instance, field orientation here. This one you can see that they're going around this, basically there's some slope here, and they're following the contour, right? Okay, going up and down the hill, no. We're not going to do that because that's going to just cause problem. Water's just going to follow that tubing down to the bottom. It's going to be very wet, and it's going to be a failed system. Okay, so you cannot go water up and down the field. So orientation is important. Location, surface drainage, that's the next thing here. Okay, look around you when you're installing that system. Look at where the gutters are from that house. What's going to come across your field? Make sure it's not going to get saturated by water that doesn't belong to the field. The water that belongs to the field is just the rainfall that comes to it, straight down, not flowing across it, and what the water we're putting into it. And that's all we can really deal with. Nothing else from that, okay? So we're talking about impervious surfaces, a roof, driveway, all those things. Make sure you're available, and make sure climate. Now, we're sort of the medium rainfall area, so here in central Texas, but if you're from East Texas, it's a whole different animal, okay? You got 20 more inches of rain to deal with, okay? And if you're on the West Texas side, you kind of go, that's not a big deal, because we don't worry about it. You just worry about if you do get some rain, it might blow out something. Okay, site considerations. Talk about that a little bit. Again, you're the one out there. You might have a site investigator go out there, but again, when you start digging and you start making, putting in pipe and things like that, some of these things are going to be coming up to being maybe the guy didn't draw it up as well as you thought they should have, and so we're going to see make sure it fits the way it should. Okay, so we have our boundaries, site boundaries, which are right here. We have our setbacks, boundary property lines, special features, utility easements, wells, surface waters, and all that stuff. Make sure that when you put that system in and you know there's a well, I would take my tape measure out and I'd make sure I'm a good, how many feet? How many feet from a well? 100 feet, and there's certain situations maybe 50 feet, okay? So depending on the treatment, quality, and all that type of thing. So there's another table, and we're not going to go to that table today, all right? Okay, some more considerations to look at here. Prior land use, okay? Is there any, well, we used to use the term virgin land out there anymore that's been unused. Very little of it, okay? Very little of it. Most of this land around here and farmed around this central Texas area here was all farmed in what? Cotton. Cotton. This was cotton was king here, okay? That's why it's very hard to grow some things, because we have a lot of brown root rot here because of all the cotton that was grown. Okay, so we're looking for these other things. We may look for the things that Sarah was talking about, compaction, soil compaction from what the thing was used for. If you've got a farm, okay, talked about animal trails. I grew up on a farm. We had a road through the farm, and that's where we drove. The tractors, the cart, anything and everything went down that road. That must have been, horrible, or still is. The farm's still out there being farmed. It must have been horrible as far as compaction goes under there, because it was the only place the tractors and the trucks and everything ever went. Okay. So that was a bad situation, and we had a soil that was not forgiving for that kind of thing. Foreign soils, buried materials. Foreign soils might be subsoils. Okay, somebody's come in here and dug a big hole because they were going to do something. Maybe we don't do basements here that much, but maybe we had a sunken portion of our house. We thought it looked cool if we could walk down into it or something of that nature. Okay, I work in states where we have a lot of basements as well, and that's a real big deal, because you dig this big old hole out and you build a third of your house down in that hole. What do you do with that soil? Okay, it's spread out, right? It's spread out. Now your what's on the top may have been on the bottom by several feet, and that subsoil is not friendly. Okay, buried materials. I've found 2x4s, pieces of plywood, a lot of concrete that was cleaned out from the truck after we poured the foundations and stuff. Those things show up, right? Okay, and future land uses. Okay, what do they really want to do? All right. So your drip field is not where the RV is going to be parked in 10 years, okay? Just throwing a little gravel out there on top of it is not going to make it useful for that. And you can't go put a swimming pool into it. However, I have had several situations where they tried to do that, and they wonder what they're cutting up when they go through these purple tubes that are coming out, these black and purple or purple tubes, either way, GeoFlow or the Netafim product, which are the only two you're going to find. That's the only two you should use, okay? You're going to run into that problem. All right, so know what's going to happen. Now, again, that little bit of information, especially about these kind of future things, oftentimes show up about the time you're finishing up the job and the house is starting to get finished, and they're going, hey, what about doing this? Joe or Danny or Sue likes to work in a shop, and we're going to put a shop over here, okay? And we just bought an RV. We got the big bonus at the office, and we're going to park this RV. We're going to put a trailer, or we're going to build a pool that wasn't thought about before. So make sure that when that happens, you're not stuck holding the bag here going, well, what are we going to do? Take it all the way back up to the top of the ladder, say, Mr. Designer, site investigator, or even the builder said, what are we going to do about this? So get everybody involved back into it. It's not just between you and the person that you're building this for. Site considerations include position, right? Landscape, precipitation, slopes. This is this is not an unusual thing if you're in the hill country, but you may be down in this guy. This guy down here is going to have a lot of problems, right? You're going to have water coming down this way, it's going to be a little more challenging for your on-site system. Okay, you may have a lot of subsurface flow as well as surface flow, and you may have to do some special things to make that go away. All right, and a lot of times that's left up to you as the contractor, because you're really going to be the one that really finds it when you get out there. Okay, so you might be the guy with the house up on top here. Okay, a lot easier thing to do, not going to be as much, tend to be problematic, but still, again, you're going to have your own special challenges for that. So back down here, and away we go. So let's talk about some of the things we look at in our drip layouts. These are not necessarily by book order and correct, but this is kind of what I see out there. So I'm going to kind of go with that, because in some counties we're not necessarily playing with the books as it's written, and sometimes the 285, which is a minimum criteria, so sometimes more is added to it when you get into the very individual counties on how they're looking at your site, your plans. Okay, so plow ends, okay? The plow end is where we go in there and we're going to pull this tubing in. We're going to cut a very narrow trench there. We're going to take this tubing on down to depth, and we're going to move it into. It's used in the good soils. It's used in soils that have some thickness, okay? And we're typically looking to place this tubing into the 8 to 10 inch range, okay? Soil addition, okay, sometimes, and I've got soil addition, and I've got a couple other soil substitutions and soil mounding. Soil addition is where you come in and you bring a little extra soil in, okay? You're mostly working with the soil that's there, but maybe it's not enough soil there. That 24 inches or the 12 inches and 6 inches, what we can do with drip, okay, maybe it's not there. So maybe we can lay the tubing very close, we'll scarify the ground, very close to the top of the surface, lay it down and cap it, and we've got our system. And now you see that a lot. You'll see that quite a bit. All right, so that would be more of a soil addition, not a substitution situation. We do some they call mounding situations. Okay, this is not a true mound. It's not a mound that Sarah's used to, not a mound that I'm used to in Pennsylvania or in states like that. Okay, it's not where we have a sand core and all this stuff and lovely ways to make the water move into a direction we want to. This is where we're bringing up the soil and we're kind of heaping it up. We'll call it a mound. Okay, there are some rules. There are some length-width ratios that we deal with in these particular mounds, but again, it's still using this brought-in soil. Okay, it's all one homogeneous particular soil. It has no structure because we brought it in and piled it up and started. Soil with structure is not done that way. Soil with structure is something we deal with when we work with plow-in systems here, or maybe even this soil addition. These mounding kind of things, it's going to be a big marshmallow in some cases. I've gone out on them where I stand up and they mush around like this. They're not taking water. The water's not going out of them because the soil, that the water is going into them, but there's no way for it to really move out. It doesn't have structure. So we have to be careful with this mounding situation. Sometimes we're stuck with having to do it, but be careful. Soil substitution is what? That's going to be where we have a poor soil. Maybe it's very rocky or something of that nature, and we're going to dig this thing out, and then we're going to bring in some called good soil, okay? And we're going to put this in there. Now, oftentimes, there's been some misunderstanding. It is a misunderstanding that if I dig out, say, a bad soil, like a class 4 soil, that's at a loading rate of a 0.1, and I just dig that thing out, and then I bring in some class 2 or class 3 soil, that now I got class 2 or 3 soil. Is that correct or not? No. But that happens a lot. That happens a lot. Okay, it is not correct. Okay, so where's the most restrictive horizon? Right under that new fresh soil, right? So it's all going to go down, clunk, and it's going to fill this thing up like a bowl. Okay, it's just going to fill it up. So if you're loading it at that rate, if that soil cannot take it, it will never take it. Okay, we don't see this too much in the smaller flows, but when we get into bigger flows, we sometimes use what I call a mulched at-grade system. Okay, and we'll look at how that kind of lays out here in just a couple of minutes. Mulch at-grade systems is where we bring the tubing in. These are going to be thin soils, typically around the Austin area. There's several of these big systems done this way. We're in the juniper cedar mulch tree areas, in the high density areas, and it's the only land we have. We go under it. We don't want to take the cedars out, okay, for whatever reasons. Okay, but we can go in there, grind up a bunch of mulch, have our tubing pinned down in the ground, lay about 6 to 8 inches of this mulch on top of it, and that's a system. And there are some really big ones over in the Austin area built that way, okay? So you may have run into a few of them, but they do exist, and it may be something that maybe you as an installer has gotten involved with in the past. But they're kind of rare, but they do exist, so just be aware that they're out there. Okay, let's take a look at what's in a typical drip system. So we're going to start at our home here. We'll start at the home. Water's going to move into our septic system, and it may move into and this may be a trash trap for an ATU, all right, prior to going into our pump tank. So in the anaerobic system, it's just going to be basically, you're going to have two separation in two stages here, like a typical septic tank. And then it's going to move on into a pump tank where we're going to have storage there, and then we're going to use time dosing. In any kind of drip system, I'll say it now and I'll say it again later, we are going to time dose. We do not put floats in there that say, come on, because you've got some water in the tank, okay? We're going to have, come on when there's water in the tank and the float is up and the clock is right, then we'll dose, okay? We're going to time dose it over how many hours? 24 hours, that's how much we have in a day, and then we start all over the next day. So make sure it's 24. So we're going to run it out from our tank. We'll have a pump in here. It comes into a headwork system here, we'll call it. Filtration package in here. We've got several kinds of filters we could have in there. Has a controller on here. Fligs it out here from our pressurized system, and it can go a long way, right? Because it is pressurized. And goes out to our zones out here, okay? Our zones do all kinds of things. We try to preserve trees in many cases, and sometimes we don't get to preserve trees. Some are going to be systems like this. Is it necessary for them to be absolutely equal? Equal. Okay, this zone here and this zone here are what? They're not equal, right? Okay, is it going to make any difference? Why not? Okay, what the conditions are, this tubing, the spacing of this tubing here is the same. The amount of water coming out of this tubing is the same as it is over here, okay? What's our loading rates? What is it called? Okay, or if you're describing it, it's gallons per day per square foot. Okay, so we're going to put this tubing out to cover the square foot of area that we're actually irrigating into. Therefore, if I run this 10 minutes and I run this 10 minutes, have I put out any more water on a square foot basis than in one or the other? I've put more water in this whole system, correct? That's correct. I probably put twice as much water. Maybe I put 200 gallons in here and only put 100 gallons over here. But on the unit area basis, it didn't change. It's the same, okay? So that's called time dosing it. We're time dosing it. We're not doing it by gallons. We're time dosing it. Most of it, probably 99% of our home systems, 99% of the systems that we deal with in the under 5,000 gallons per day are going to probably be done that way. Okay, so let's take a look at some of the things you as an installer may be seeing on plans. All right, this is a isometric drawing where you're looking at kind of taking the soil, creeping it back, and say, what does it look like for the tubing underground? Okay, and we give this illustration here. We've gone down this far, so many inches, so many feet. Say 10, this is 8 to 10 inches down here. We've got our tubing going back and forth across here. This could be a very long 100, 200 feet, 300, up to maybe 400 feet of length in here, okay? And it goes from this side where the water comes in, it goes to this side where the water goes back. We use closed loop systems so we can flush our tubing. That's how we keep our tubing clean, is we flush it. Okay, so you always going to have a closed loop system here where it comes in. The only way the water gets out is through the drippers. Okay, that's the only way the water can get out. Other pieces of equipment here, air vacuum relief valves and cleanouts. Let's look at another illustration. Okay, here's one where this is probably a more popular way to do it. Is we go out here, we have one trench. We put all of our piping in one trench, and then we go out here, come out some distance here, halfway of the length here for our lateral line here. This is a lateral from the end, beginning and the end, be where it comes into the tubing and goes back for the return side. Okay, and this is looped, okay? Loop systems, that's a very common system. Sometimes it's the geometry that causes us to do that, and sometimes it's the way that we're going to be able to get in there and construct this, because we can dig one trench here, and the loops we can pretty much handle with a shovel. Okay, a little more elaborate design or look of it. These are the kind of things you see on plans. These are details. So if you're getting into the 5,000 gallon per day systems, you're probably going to be seeing engineered plans, people that are engineers or advanced designers, and they're going to be using AutoCAD and that type of thing. So this is a detail you would see representing what we just looked at here. It's our distribution headers here, as where we're bringing the water in and where we bring the water back. There's zone valves here. This is check valves here. Okay, it's between our zones, making sure all those things are there. Sometimes our zone valves are back at the beginning of the headworks, and sometimes they're out in the field. So we'll have those kinds of situations. But this is typically what you're going to see in on a set of plans that you have to interpret as the installer. Okay. All right. Here's an end-to-end one. This is a detailed representation of it. So we're bringing all the water back and forth here. Okay, and so that's again. So and it contains all the parts and pieces. It's going to be called out on here. These have detailed numbers here. What kind of valves? What kind of check valves? Those things all ought to be on the plans. I don't care whether it's a single-family home or it's for a school. All those kind of details should always be in the plans. If not, the designer's not doing his job completely. Go back and ask. Don't try to guess it. Okay. Okay. This one is another loop system, but I put it in here. All right. This one here, we'll use two different terms: elevated manifold system or top-down manifold. Those are two type systems here. And what happens here? The elevation is going up this direction. So the top of here, my black curtain here is our up direction. We'll put the distribution headers up here in the top. And then we're going to send down individual lines to catch one or two of these laterals. Okay? And what that does, it keeps us from having, when we shut down the system, it keeps the water from coming back and spreading all over the places, going down to the low spots and creating wet spots. Okay, that's what we don't want to happen. So this was a concept that came up with, and what was nice about it was it didn't have any moving parts. Okay, we can do that kind of with check valves. I can put a check valve system together to make it do that, but eventually a check valve will fail. Okay, it's a mechanical device, and we'll have to replace it. This concept here, although it's a bit pipe heavy, has a lot of material in pipe. It has no moving parts. So it's going to not corrupt itself just because something wore out. Again, you'll see those on plans. I threw this illustration in here. This is a typical at-grade installation where we're doing a mulch job. This is coming off a set of plans I'm reviewing right now. Basically, you've got this system in here. You'll see we're coming in here, and we know we're going to have mulch on it. We know that's what's going to happen to it. So we're coming in here at the natural ground. We're laying the tubing out. We're pinning it. Okay, the installer's going to come in here, and he's going to pin this thing. And then they're going to bring this ground-up mulch. It may be tree bark mulch. It may be all kinds. You want something that's going to last. And it goes in the denser areas where the junipers are and a lot of oaks. Okay, what's going to happen there? Do you know why they do it there? One, we don't want to tear the trees out, but the density of the trees helps do what? It helps to replenish it. What do those trees do? They shed. Okay, even though the juniper is basically an evergreen in a sense, it still sheds. Okay, and so do our oak trees and everything else. So we're going to come in here and put 6 to 8 inches of mulch on top of this thing, but we don't want to have to go back in there every year and replenish it. Now, we are required to if it comes uncovered, but we want those trees to do it naturally. Okay, so that's why we want to be under a dense area. So the state's not going to let you do this kind of thing. The county shouldn't be letting you do this if there's not full coverage of a canopy of trees over it so that it's getting that replenishment. Okay, so that's what that's all about. This is a typical plan I see kind of a lot of, and this kind of goes into the soil addition. I'm not even, in some cases it might be the substitution, but this in the case is a soil addition. Okay, what we have here is our tubing has been blocked out here. That typically indicates that the designer was thinking that they were going to come in here with a small trencher and cut these lines. Okay, and then the tubing was going to be put into the trenchers with this soil, and then we're going to bring this other soil on top of it. Okay, they talk about this, the term was used, till the ground. Well, we don't till the ground, we scarify the ground. We want to do the scarifying in such a way that we're going to make it easier for these soils to blend together. It was talked about in the last talk. Sarah was talking about when you do those kinds of things, make sure the moisture content of the soil is right. If it's too wet when you do that and you smear that soil, that interface is going to be blocked, okay? It'll never work. So we want to make sure we're doing it to the right time. Sometimes that soil is a mix of fractured rock and blacklands around the Austin area, and we don't really have too much of that problem, but that's what you may be running into. But so scarifying, if you don't know how to scarify, you never had experienced that, and you get into one of these situations, you want to look it up, talk to somebody that's experienced with it before you do that kind of thing. Okay, a installer kind of thing. There are two different kinds of connectors that are out there. I'm just showing the one that I prefer, and just because I prefer it, you've got barb connectors that push into the tubing. Okay, this is important because these are things that come apart and cause you a lot of headache. All right, or you have fittings that have well, here this one is called a power lock. There's 2 or 3 varieties on the market out there, and what basically happens is you push the tubing onto a less aggressive barb, and then you turn this basically a nut over the top of it, and it clamps it down. So it's a coupler. It couples the tubing to the fitting, and it's a tough deal. It's a little easier on the hands, a little easier on the installer, and that's what I've always pushed for it. And it also allows you, if you use the right one of them, that if something were to go wrong, you say, hey, I need to undo that. You can do that. You can't do that with a typical standard barb connector. Okay. And when you're doing loops on the other side, you're going to typically have 2 ways to do it. You can either bring the tubing on around, okay? I recommend that you do it with a flex loop here. This is flexible PVC. And the reason I like that is it takes all the possibility out of it of kinking that tubing when you make that turn, okay? Depends on what time of the year it is, whether or not it will kink easier, whether it's cooler or hotter, whether it'll kink. The way the tubing is manufactured, some of it kinks worse than the others. Okay, when you bury it in the ground, it can still kink from the change in temperatures, and you won't know that. Okay, will it be necessarily a dead line, the part that kinked? Okay, will it be necessarily a dead line? No, because it can go around into circles. Okay, all right, because it's a closed loop system, it can come back. Let's just take a look at a few of these systems here with the time we've got left in here. All right. So this would be where you're going in and you're doing a soil substitution here, or you're going a situation where you're going to add soil on top of it. So they're not plying the drip tubing in here. They're laying it down, and they're going to come back and cover it with an adequate amount of soil. Okay. Here's one. So we had this picture a while ago. Well, that's what these guys are going to do here too. They're going to lay it all out, pin it down, and then come back in here and run another 8 to 10 inches or 6 to 8 inches of soil on top of it. Since the soil will settle, take that into account that it is going to settle. So when you have that remaining depth to be in that 6 to 8 inches, not what you start with. Here's the situation on a little bit bigger system here. This is on a youth camp, and this is don't pay attention to much of the stuff in the back, but here's our manifold in here. This has got a lot of elevation in here. We're doing that elevated manifold system here. You can see all that stuff there. Here's a plow-in system. They have very good, nice soils. And this is what it looks like when you plowed in with a narrow plow. Again, here's the elevated manifold system that's feeding a couple of the laterals as it goes down. Okay? So you may be putting something like this together. This is what they'll look like. If you haven't done that, you'll see this. This is one that is not a good idea to do. It's a very bad idea to do, and you don't want to do it. This was an idea of an installer, and I won't say who it was and what state they were in, but they decided they did take the 1,000-foot of drip line that was supposed to be for that particular site, dig a deep hole, throw it down in there, and plug it in. They did it on several of these things. And I love this picture. It's just great. That's why I said it's a really bad idea and don't do this at home. Okay, but it did work for a while until it got boiling up out of the ground. Okay, so you never know what people will do. Electrical hookups. Guys, y'all are the installers. Y'all are going to be the ones hooking up the pumps, setting the controllers and stuff like that. You're not electricians, okay? But you need to learn the skills of an electrician because you're doing all these things. You've got to hook up controllers, pumps, floats, all those kinds of things in there, and they've got to be hooked up right. One of the things that we have in our wastewater is what? Gases, right? We have gases, and so those gases can give us problems. What is sewer gas, you want to call it, or hydrogen sulfide, do to copper? Oh, it eats it up. It loves copper, right? Okay, so if you're not making the right kind of connections, if you're bringing your setting controller and you've got a line out for your floats and you didn't seal that off, that gas just comes up into that controller and it eats it all up. I hate that when that happens, but it does happen. Okay, so controllers, just to see what some of them, oh yeah, I've seen that one. And you say, yeah, I may have seen that one. Oh, that's the big one there, but you may have not seen it unless you've done commercial jobs. Same thing. Make sure that the wiring is done to code. There is a code out there. Even though you're not an electrician, you're still required to follow the code and all that good stuff. Otherwise, you end up with this. Okay? How many seen this? Yep, I'm done. Yeah, there you go. There you go. Probably more than you're willing to admit. This can happen. This is just eat up. Just eat up. So I don't want this to happen. So do the best you can, making sure you do all the right things. We got usually two kinds of pumps. 99% of us are going to be doing it with turbine pumps like this. Maybe there's middle suction, maybe there are bottom suction. Okay, that's going to be the two things. See a lot of them out here on the floor. Or getting to a little bit bigger system, 1,000, 2,000, up to 5,000 gallons a day. You're going to have some pumps like this, self-priming, 3 to 5 horsepower type pumps. Not unusual. Again, make sure you wire it right. Okay, filters. It is a necessary for the health of the entire system. You must have a good filter. Okay, must be capable of flushing manually, continuously, or automatically. Okay, must be accessible. Should not be installed in risers that are buried. Okay, if you're going to bury the thing, how can you do maintenance on it? Okay, so don't put it in something that you can't get to. In commercial applications, this is just something I really believe strongly in. Commercial applications should you only use automatically flushing filters because you don't know who's going to be taking care of it. If you're at a travel stop on I-35 or you're at a school where they don't have enough personnel, I mean, sometimes the janitor is going to be also your wastewater engineer at the school. And so you want to make his life easy as it can be. Okay, handful of filters here just as we finish up. These are manual filters that have a flushing it flushes constantly. It's called a surface flush. Uses disk filtration here. This is another version of it where you have multiple zones. Okay, those are simple filters. They don't have a lot of energy. But you're going to have to take them apart 2 or 3 times a year. How many times do we visit our sites a year? 3 times, right? Okay, take them apart and take a look. This is another system that we've been out there quite a bit. This is using a screen filter. Okay, right here. These are all manual valves, and you open and close these on that visit that you go out there 3 times a year. Okay, automatic flushing filters here. This is the Tough Tiger. You'll see it out there. Rudy's got them out there. Okay, no electricity. This one is similar to the manual one we saw a minute ago, but replacing the manual valves with hydraulic valves, right? Here's a little more sophisticated one that's used with one of the systems that can go with the anaerobic effluent. You'll see that out there at the J&M's booth out there. All right. Here's another version of the same thing going into it. These are automatic, totally automatic filters. This is for a small commercial. This is for the Perkrite system. There's only 2 of them that can be used in the state of Texas, and you've seen them both now here. Okay. Installations. All right, real quick here. We got just a few minutes before the beer opens up. Trenchers. All right, 4-inch trencher. Okay, what's he doing here wrong? He's opening all of his trenches up at one time by going back and forth, back and forth. So what's he doing? What's really wrong here? He's walking over this what he just put up. So he's going to try to roll that spoil back in there. It ain't going to happen. He's compacted this thing. We've just been talking about don't compact things, and now we're compacting it. So this makes a really bad way. There's a lot of systems go in with this type of technology. Really bad situation here where we have to come in with a rock saw and cut our soil because our soil has so much rock in it. Not a good situation. You have to bring in soil on top of that. Just, again, that's kind of our world here. Landscape plows, they look good, they look cute and everything else, but they're not self-propelled, and they might do a nice little hole, a nice little trench, but really tough to get a system in. So I don't necessarily recommend it, but it's there and it might work for you. All right, plowing systems. Okay, vibratory plows probably do the best job with smaller equipment here. We've got our tubing here, we've got our plow ready to go. All right, so we go. Get in there. Here's another plow. If you haven't seen the working ends of a vibratory plow, this is it up close and personal. All right. So it comes in here, the tubing flies through here, comes out there. These pads over here keep the depth. All right. Here it is getting ready to go into the ground and get going here. This is one where a person likes to do, they open the trench first, drop the plow in there, and pull across, turn around, and come back. Oops. There's a similar machine walking. You can even do it holding and drinking a Coke while you're going along. That's just how easy it is. All right. All right, here's a machine that's a Vermeer machine here that's been developed for tubing installations, and we tried to adapt it for the on-site. And the only reason you know that because the tubing's purple, okay? Here's a similar machine that was with track. This one's been used quite a bit here in the Central Texas area. Works well. Soils have got to be right. You can easily overpower this thing when you're trying to get that tubing deep, so you're maybe limited on the amount of tubing, down to depth of plows and how many plows you have, okay? I took this picture here just a few minutes ago before I came in here. This is a machine it's brand new, hasn't been out. I'm not here a Vermeer salesman, but I just thought, geez, it's here, guys. The Vermeer guys are here. Go visit it. Have a look at what a machine like this looks like. And it's a little bitty dude sitting over there. And this is the one that you could take in the back of a yard. It's no wider than the opening of a gate, okay? So if you're looking at this, you say, well, I never can find a machine. Here it is, okay? There is one here. There are other ones. Ditch Witch makes them, Vermeer, but they just happen to have one here. Case makes a nice one. The other things are static plows. We pull these things with more horsepower, okay? We're going to draw that thing through there, okay? You say, well, do they do that more often? Yeah, we do. It does a nice job, okay? We can get bigger. Now we're looking at something going to pull with 150 to 200 horsepower. Over 30 acres. This was done on a 30-acre site near Dripping Springs, okay? That was the plow they used, okay? Here's a plow that comes out of the state of Missouri. I have an installer dealer over there. This is the one he built. It does 6 of these things at a time. Okay, here he's got it in the ground here. This is a tracked John Deere tractor. I know this is a little bit bigger than stuff, but this is for a small school at 3,000 gallons a day. Okay, this is what they ended up using here to put this thing in the ground. So it's not out of your range of potentials that you can use. World's largest single trencher. Okay, world's largest single. This is a D9 cat. It had a spool on there that would hold well over 100,000 feet of tubing at one time, and this is what this guy was using. So this is up in the mountains. It's really pretty neat up there. Okay, so I have skidded into the last 2 minutes of this between you and the beer. Any questions? I'm sorry how fast it goes. Next time we'll do this. This should be about a 3-day lecture. We will really get into the meat of this thing, but this is touching it. Thank y'all. Very good. We'll see you.